11.7 volumes of similar solids. Find the volume of each cubed. Cube is going to be the same length on all sides, 3 times 3 times 3. So the volume is going to be 3 times 3 times 3, or 3 cubed. 3 times 3 is 9. 9 times 3 is 27. The volume of this cube is going to be 6 times 6 times 6, or 6 cubed. 6 times 6 is 36. 36 times 6 is 216. Now, what is the relationship between the volumes? Is it double, like you might think? Now, we see that the lengths are double the size of each other, but the volumes are not double the size of each other. So the relationship between them is a cubed relationship. Note that the side lengths are a cubed relationship, not double. So recall that when we are calculating lengths, areas, and volumes of similar solids, so if they are the same solid but just different sizes, the length is going to be a regular relationship of A to B. You just compare the lengths. That also includes perimeter. Anytime you're working with the perimeter or length, it's just comparing them to each other, A to B. When you want to scale up and you want to compare the two-dimensional shapes of similar solids, it's going to be an A squared to B squared relationship. And finally, the one that we just saw, if you want to compare the volume of similar solids, it's going to be A cubed compared to B cubed. So let's try this example. The volume and radius are given of figure A, and the surface area and radius are given of figure B. They're both spheres, so they're similar figures, and we just know one of them is smaller, 12-inch radius, and a 20-inch radius, and they've provided us the volume and the surface area. If we assume that A and B are similar, find the surface area of figure A. So the first thing we need to do is write down our comparison between our length, areas, and volumes. So the length comparison here is going to be just the radius comparisons. So it's going to be a 12 to 20 comparison. Recall that you can reduce that. 12 to 20 reduces to 3/5, which gives us an area relationship of 3 squared over 5 squared. 3 squared is 9, 5 squared is 25. And then the volume relationship is going to be 3 cubed. 3 times 3 times 3 is 27, and 5 times 5 times 5 is 125. So now we can use these relationships to set up proportions to solve for missing pieces. So if we want to find the surface area of figure A, we're going to be using the area proportion. So we're going to have a 9 to 25 relationship between the areas. I don't know figure A, so that's the piece that's missing. I do know figure B, which is 1600 pi. Then we can cross multiply and solve, so 25x equals 9 times 1600, which is 14400 pi. Divide by 25, so the surface area of figure A is going to be this divided by 25, which is 576 pi. And there is units, so that's inches squared. What is the volume of figure B? So volume, we're going to use our volume relationship, 27 to 125. Figure A's volume is 2,304 pi, divided by the unknown volume of figure B. Cross multiply 27x, 125 times 2,304 is 288,000 pi. Divided by 27, so the volume of figure B is, and let's leave it as a fraction. We don't need to take it to the decimals, so that's going to be 32000 divided by 3 pi inches cubed. Thank you.